Welcome to the Edgevana Podcast, where we illuminate subjects in the IT infrastructure space. Get ready to hear some amazing insights from outstanding individuals that will change the way you think about IT. And now, here's your host, Mark Thiele.
All right, hello, everybody. Welcome to another edition of the Edgevana Podcast. I'm your host, Mark Thiele, and joining me today is Lori MacVittie from F5. Lori, welcome to the show.
Glad to be here. Thanks for inviting me.
I can't believe we went this long without having you on sooner. I always enjoy our conversations about what's going on with cloud, what's going on with modern infrastructure and networking, and certainly, as I think the audience will see, our discussion topics for today will weave together kind of all of those subjects in the environment of Edge. So I'm really looking forward to getting your perspective there. So before we get right into the meat of it, Lori, tell us a little bit about Lori and about what you do at F5.
Wow, telling about me would take too long. So how about what I'm doing at F5? So I'm in the office of the CTO, Principal Technical Evangelist, which is a really fancy title for knows things and writes about them a lot.
I just write about them. I don't even know about them. So you got a step ahead of me. So
that'd be easier sometimes. I just want to say something about this because I don't like the way it sounds. Yeah, it's like sometimes you hear things, but then I have a developer background, so I get really driven by, well, I have to understand this before I at least pretend to have an opinion. So I do a lot of research, a lot of studying. I try to read the internet, read reports, try to synthesize what's going on and what that means for just IT in general. How does that change applications and infrastructure and where we put things and how we construct them, and then make that make sense to F5 and its business. So it's always changing and it's always exciting. So we get to do new things.
Yeah, neat. I mean, the cool thing about it is it sounds like your job in the office of the CTO is actually pretty close to what the expectation of a CTO would be, or the office of CTO. I mean, as you've probably seen, it seems like the definition of CTO has changed significantly since the 90s, when it was very technology driven, either the technology the company used or the technology the company sold, but that was being driven by the CTO. And in a lot of companies, that's not the case anymore.
No, it's not. And for a long time, F5 actually had a very engineering focused CTO. It's focused on the inside and how to leverage technology for what F5 delivered to the market. And now our CTO is more focused on outside in. What's happening in the real world, as it were, and how does that impact what we deliver and how we deliver it, and on the business as well. So it's a different shift. It's more strategic. It's more what's going to happen in 2 years. What do we need to start preparing for? And that can be really hard, but it's really exciting because you get to look at so many new technologies and new ways of solving problems that sometimes you're just overwhelmed. Like I just need a typewriter. It just types words. We'd be good.
No, I feel that. I mean, it's actually part of been a part of my job for the better part of 10 years now to see what the industry is doing, how people are buying, what technology trends might mean to adoption strategies, things like that. And I find that to be one of the most entertaining parts of the work that I do, is helping to translate that into action internally or suggestions for customers in the market, and is constant fodder for blogs if I let it. So,
it
awesome.
generates a lot of content, just translating some of these things, when NFTs started showing up. I mean, if everyone from marketing to technical, folks, to my 13-year-old are asking, what's an NFT? Should I care about this? And if you haven't looked into it, it forces you to go, well, I don't know. what could this be? And so it starts you on a path, and you start, looking at it, trying to, well, it doesn't apply, it does apply, how could you abstract it? Where does it fit? Does it fit? Questions like that are fascinating to explore just about every day.
Yeah, awesome. I totally agree. All right, well, let's jump into this, the hard part of this discussion, the meat, as it were. We exchanged a couple of ideas before the podcast, and I agree with you that almost any of these are a session unto themselves. So I've picked just two broader questions that I know that we can expand on. And I want to start with the first one around application design and edge. You know, what do you see in the form of edge native patterns? What do they look like? Why are they different from what people think of today as cloud native or even infrastructure flexible, for lack of a different description?
Ooh, that's a new one. See, now I have to. What's infrastructure flexible? Is it flexible, fluid? Ooh. So I when I started thinking about, right, how do applications change because of edge, or how do you take advantage of edge with an application, right? A lot of people, when cloud started, made the mistake of lift and shift, right? And they really didn't see the benefits. They didn't get the advantages because they just took what they had and they put it in something new. And, I worried that with edge, we're going to do a pull and toss. Whee,
Yeah.
Maybe will it work? I don't know. We'll find out.
Right.
And there's differences in, right, why you would want to use them. And we already see some of these patterns emerging. And there's two distinct differences. One is it really focuses on also distributed data as well as distributed applications.
Right.
And then there's this construct of we're pulling operational data along with informational data, right? So it's bringing OT and IT together, and these applications have to deal with it. So, you've got combinations of things where your app on the edge is actually supported by an app in the cloud or the data center, but often the cloud. So you've got this new tier of kind of an architecture that requires the cloud, the edge, probably an endpoint, and then trying to figure out where does data flow, what kind of data flows, where's control. There's just all sorts of different questions that come up in that architecture that start falling out into certain patterns, like a store and forward, right? For a Tesla car, you might be pulling all the data from the endpoint to an edge node and then forwarding it later.
Yep.
Right. So you still got many tiers, different pattern from something that's trying to enable remote control. You might have control from the cloud, but you have monitoring and alerts locally on your phone for this thing sitting over here. So you've got two different pieces, and there's all sorts of interactions that go on there and things under the covers, but it changes how the data flows, and what the security requirements are and connectivity.
And so, gosh, there's so many questions I'd love to ask in this, and we're not even near going to have enough time. I'm just going to pick a couple. When I think about edge, I think, I think about a lot of things, but specifically on this particular topic, when I think about edge, I think about resiliency designed into the application as opposed to into the infrastructure, knowing full well that there isn't a single design pattern for app deployment out to the edge, and there probably won't be for some time to come. Some of it will look like a distributed cloud where it's a single cloud in a lot of places. Some of it will look like distributed infrastructure where you have relatively automated infrastructure, but each one is a distinct unit. When you think about the former, though, when you think about application design from a resiliency standpoint and the knowledge that even if you have, say, 4 or 5 edge locations in a relatively speaking near to each other, co-located, for lack of a better description, maybe not in the same building, but in the same city or same state or something. How do you accommodate the complexities of trying to solve for something like Netflix Cassandra database solution for global access to to profile, et cetera, et cetera. How do you accommodate that? Because you mentioned data earlier, and I completely agree, right? I mean, not only do you have to maintain the policy piece, which is really kind of more operational, but you have to actually maintain, for many applications, what data actually makes a difference to continuing the transaction. So how do you think about that in app design for resiliency at the edge?
Well, and I think there's two different approaches to it, right? One is that, right, the app itself should worry about that the app controls the resiliency and the access to the data, where it is, and it's responsible for that. The other one is that the app would treat it a lot like it treats the network and even TCP, right? Especially in cloud native apps where we just assume that it's reliable in there.
Right.
And then we let the infrastructure handle the data. Basically, we make the data a first-class citizen, right, with the application, and say, look, its access and availability and policies is just as important. Do we, I don't know, not necessarily cache, but do we, replicate the pieces of the data that we need in the right location in order to bring down the size and the cost and, right, the access, which it certainly would if it's a smaller data set. Do we do that? Yep. Or do we, just replicate the whole thing, which seems kind of ridiculous in this day and age? I think there's two different approaches to it. And developers have so much to worry about already that, I kind of lean toward that latter, where I'd rather see like data become its own right thing rather than being secondary, and we treat it like that, especially given concerns over privacy and compliance and regulations around the world, that it actually needs more attention than it's getting in terms of where it sits. So maybe we need to build that into those patterns, that the data has its own set of policies and requirements for resiliency. And the app developer just has to say, look, I know the data should be, this is how I access it. And something else is going to take care of that for me.
Yeah, and that's you bring up what I believe is one of the most critical points relative to the data and its residency requirements. Throughout history, and I'm sure you've dealt with it. I mean, how many people have written firewall rules on a router, or written firewall rules on a firewall and just never gone and removed them when they should have, when that requirement went away, things like that. So it's pretty much, it should be accepted. If it's not, it should be accepted that manually writing policy for what happens to data for every application and every transaction opportunity is unlikely to be successful long-term, and especially at any kind of scale. So do you think that there is a best practice? Do you think that this is something that just has to be intelligently coded into the application to look for things like addresses or longitude and latitude, or that kind of thing ahead? I mean, how do you see that working?
Wow. Yeah. So, I mean, and the most common situation that's usually brought up when we talk about data and residency requirements is GDPR, right? Where can the data go? And I think that's one of those cases where, your master data, wherever that might be, is replicated into smaller chunks of, all right, this is for this region, right? So you can have a copy of that, or maybe it's cached, or it's somehow, right, I mean, abstracted into a way that an application, yes, I mean, from it would almost have to be tied to user, wouldn't it? Because location, I mean, and that's a question I've never looked into. So if I travel, I'm from Germany and I travel to the US, does that impact, right, data requirements? What data, right? So it really can't be based on where I am. It has to be based on who I am and whether I'm, I fall under that requirement, which seems to be tied more to identity, which, right, we do see identity kind of pulling everything toward itself in terms of security, because that's the only thing we have to really nail policy down to now. We can't do IP, we can't do, device, we have to do who are you?
Right. And it's much more likely to have that information be maintained and accurate than it is for anything that you or I have to try to remember to do before we go to bed at night.
Yeah.
Yeah, 100% agree. So one kind of silly question before we move on to the next topic. Do the discussions that we're having right now and other discussions and designs being required for Edge mean that we need an ENCF, Edge Native Compute Foundation?
That is a very good question. I
Because
mean,
if I was, okay, so I'm going to give it to you for free. But, if I had to pick, there are a number of areas where it'd be really easy to say they're the most important thing, right? But I think it's de facto that it's assumed that if it's not number one, it is tied for number one. And that's how all of the different aspects of networking will apply to edge computing, right? From determining latency success to determining optimal utilization of bandwidth to security, to delivering security localized versus having to centralize it, to being able to protect environments from a security standpoint via the network. I mean, the list goes on, and that is individually smaller increments, but over a pattern of edge locations, a fairly complex story to design. And there isn't really a group like the Cloud Native Foundation looking at that aspect of edge, right? From the pure network standpoint.
that is true. And I think you do need something like that, if only to provide, best practices, or right, if there are going to be new protocols, right? I hear P2P brought up a lot when it comes to edge, why this isn't more integrated into different types of applications, especially when you get into things like gaming or sharing of content, right? I mean, live chat, things like that.
Yep.
And there's no real good standards around that. How do you do that? How do you determine that? How do you build resiliency into those systems? So, some kind of organization or group that's, trying to determine that and give people best practices before they start re-architecting their global network, which, our research says a third is going to, which is kind of scary, but they are really looking at the network going, this whole edge thing, it changed everything. So now we need to relook at our network. You're right. But nobody's really giving them guidance about, well, what does that mean? How does that change what you used to do? Right. So good idea.
Okay, so if F5 executes it, I just want my name in the credits.
Okay, that's right. Mark idea.
Excellent. All right, so next topic, and this one is, it's one of those that has been sort of like the upside down pony on your desk or table behind you. It's been a unicorn dream of people ever since the age of VMs and the initial age of cloud, and that's portability, right? So you particularly mentioned in our conversation before the podcast, Edge 2. How do you think about the ability to provision apps anywhere and that kind of portability? Are you thinking about it from a live portability standpoint? Are you thinking about it from a propagation of application access? How are you thinking about that?
Actual live movement with very little disruption. And I say that, I used to, weeks ago, I would have said that with that's very aspirational. But last week I sat and watched that actually happen, where 2 or 3 of the microservices that make up a container-based application were just with a script moved from one location to another. And, then you could see in real time the performance implications of moving not just the application as a whole from one location to another, but pieces of the application. What if I just move these front end services? What if I move the product piece, right? The product service, and I put it over here. And it was moving across different cloud properties. So from one to another, because they're containers and there's a foundation, a stack that supports that, can actually just move those pieces of the application from one place to another in near real time. You can't do it instantaneously, of course, but it was, within 2 minutes, one to the other, which is incredible in terms of, we were promised that with virtualization, and you can do a live migration, right? I've seen it demonstrated, I've seen it done, but it is a long, more complex process. Right.
And it's not as if you're, so when you think about that kind of portability, do you see it more of like follow a user around? Like earlier we were talking about policy and people's data. What if that data and your policy are required for successful interaction with an application that you're using as you're moving quickly across a landscape, like i.e. on a 300-mile-an-hour train or something? Would that be a use case for that kind of portability, or would it be more around resiliency, like protecting against latency degradation, or availability of compute resource, things like that?
So, optimally, in an ideal world where all of this is built out and it works, right, it would move with you personally.
Yeah.
I think initially the way that we'll see that kind of functionality rolled out is more about resiliency and then the application design. So the demonstration I saw was specifically focused around helping developers and DevOps understand the implications of the performance within the application, right? As opposed to, me over there. But so in terms of resiliency, I think it's more that you'd see an entire application moved from, one location in the world to another location in the world, or actually duplicated. So it's not that it has to move, but it could be cloned to say, wow, we have a lot of users suddenly coming from X, and their performance is suffering. Let's move that over there so that they get good performance and we don't impact this other one. Yeah. So more like that kind of resiliency. I think that's the first use case, is the whole application.
Yeah.
And I think there will be some that will experiment with that, moving it around in order to determine where is really the bottleneck in this application. What is causing the performance problem? And then they'll be able to determine how best to distribute that in the future. But resiliency first, I think.
Yeah, I think, and I would agree with that. I don't know that nearly as well as you do, but it makes sense to me. One of the concerns that people have in the, even though uptake continues to be strong for serverless, one of the concerns historically has been around latency of the functions in a serverless app, right? Do you see the potential based on the size of a serverless function or the sensitivity to latency as being an opportunity space for effectively distributing specific functions to areas of a network of capacity where they get the best performance and the best response for the customer or the application as a whole? Or is that just too much of a pipe dream or even unnecessary? Don't be afraid to tell me that's a stupid idea, Mark. Nobody would ever want to do that.
Why do you want to ask me these questions? I don't understand. No, I think wrapped up in your question are a lot of things like, one, for my application, for this function, what are the performance expectations? What latency is acceptable? What latency isn't? Right now, when we do monitoring, and as an industry, this is true, we tell you what it is and you tell us, is that, okay, and you kind of set it in there, but you don't really get to say, look, I need this performance out of this. It can be no more than 100 milliseconds, has to respond. And then there's no system that can take that and say, okay, this is the best location for you to put that thing then.
Right.
And I think, if we can make those, small steps in between, like first, let's get people to be able to define what their expectations are for the application. Then we can start looking at how do I meet those expectations, right? We kind of have to turn IT around. It's more, well, we promised to give you this much latency, and the app developer stuck, well, but I need Y, and you
Right.
can't give it to me. We have to flip that script, and we
Yeah.
have to start aligning with business outcomes, right? We need this to be this fast, because otherwise, right, we lose money, or people can't, talk to X, or we can't do Y, or, there are implications all over, like, digital 911, right? I mean, I expect this to be fast. This call better go through, or this, thing better talk to it quickly.
Yep.
I expect to be able to define the performance requirement and then have you meet it, not you tell me what you'll give me. So it's
Right.
this has
I,
to shift.
I would agree. It seems, especially for somebody like me who has historically been more comfortable with, you know, defining the requirements of building a whole data center, or operating a whole data center, or operating the server and storage infrastructure inside a data center. Networking has never been my strongest suit, but even with my limited, certainly as compared to somebody like you, my limited knowledge of networking and performance management and many of the things we're talking about here today, it seems like there's still a real problem in people understanding even where latency plays a serious part in the design of their app and the ability to deliver that app effectively. Like, I get questions all the time. So, Mark, well, if 5G comes in, it takes LTE and drops it from 40 milliseconds to 1 or 5 milliseconds. And I'm going, okay, but that doesn't change the fact that as you move data over longer distances, actual bandwidth utilization degrades. And depending on the design of your application, even if it does work for a single transaction and a single handshake in 100 milliseconds, what happens if you have 3 or 4 handshakes? Or what happens if the packet size is not optimized for the bandwidth and the distance? And then you still have to think about the latency associated with, well, what kind of storage did you pick, and how much RAM do you have, and what CPU are you using for that application? How much wasted function is there in the specific application design itself? And so there, to me, latency is one of those things that's almost got a magical connotation to it, in the sense that if you're really thinking about customer success, you should be squeezing every ounce of wasted latency out of every part of your application delivery. And it seems to me that even among people that should know better, because I had this debate with senior telco network engineers at a previous company that were arguing, oh, nobody needs that latency, 100 milliseconds is fine. And I'm going, really? Because I got a bunch of apps and data centers that I've deployed all over the place where 40 milliseconds for a heavy user was a real crusher, because it wasn't 40 milliseconds. That's like saying, oh, it only takes 10 minutes to get to town. When is that? Well, if you drive at 3 o'clock in the morning on a Sunday and you break the speed limit, then it only takes 20 minutes to get to town. And so what's your perspective on, thinking about latency in general, especially considering, the complexity of edge and the amount of data that's likely to be captured there, et cetera, et cetera.
Wow, latency bad.
Yeah.
It makes my gaming bad. I don't like it.
Yep.
So I think, part of the thing is that we use the term latency when we actually mean response time.
Right.
That's the other part. The latency is induced by, the network, by the speed, by the load on the, the hops in between. And it's very specific. It has a very specific meaning. And, you can't get to zero, right? Laws of physics. We can't get to zero. We're always going to have a little bit.
Right.
And, the networking minimizes that. So excellent. But, even if we say we could get the latency to zero, it was just that good. You're still, your response time, as you pointed out, is still impacted by, there's a handshake, there's, decryption, usually, we're doing secure stuff here, processing time, intra-service latency, which is really, again, response time. How long does each of those services have to process? There are so many variables in this equation that, to just say, well, latency, it's like, let's really move it up from, let's not talk about the network piece, which is latency. Let's go all the way up to the top and say, how fast do I need to respond when you hit that button? When you say go, how fast do I expect a response to come back? Because these two values are going to be different. And the top one is made up of all sorts of things we can control.
Yeah.
Right. We can't control necessarily congestion on the internet. We can route around it. We can't control, the time it takes, the load on the server, but we can, right, scale out so that we reduce the load, improve the performance. There are things we can do about that. But when it comes to latency, there's so many variables we can't control. We can only try to work around that. At some point, we have to go, latency is going to be under X. Now let's use the rest of that to try and impact what we can, which is where are these pieces sitting? How many services did you break your application into? Because if you did 100, I'm sorry, you're not going to get that response time down where you need it, because I can start doing the math for how long it takes to do X, Y, and Z, and we can't make it, right? That's going to impact your application design. Yep. And so I think there's some amount of like education that needs to go on with not only developers, but architects who design the systems to go, look, this is what actually impacts performance. And even moving it closer isn't going to change the fact that you just built 100 services and your latency is going to just be bad. So, we just need better, right? It's not that we shouldn't try to reduce latency on the network or, go past the speed of light. Wouldn't that be awesome?
Yep.
We're going in reverse. But we have to recognize that it's not just the network.
Right.
Stop always blaming the network. A lot of times it's design, it's processing, it's load. Right? There's so many things we could do.
Yeah.
We just need maybe a system to tell us what that problem is.
Yeah, and that's I really think that's a hard nut to crack, right? Is to although there are expensive tools you can use to measure the click to IO and return performance of an application, it isn't necessarily very good about putting 24/7, 365 randomness into the equation, nor impact over time of increased utilization or longer search times or whatever the case may be. But yeah, I see that as one of the key opportunity areas for people being able to quickly get an idea of where they can affect real improvement. And to me, it's kind of like if you only ever drive your car to the store, the fact that your gas cap is open and slowing you down on the drive is likely unnoticeable. You've got stop and go traffic, it's not a very long distance. But if you drive 100,000 FedEx trucks and they drive all day long and their gas caps are open, all of a sudden it's a real problem. It sounds stupid, but those are the kinds of things that we need to look for as we think about deploying applications, especially if we want to actually demonstrate to the customer the benefit of being at the edge, right? I mean,
yes, yeah. Well, it's right. We have a lot of data. We don't seem to be able yet to find the patterns, establish the relationships between, oh, your performance is bad because you had the gas can, was open. The gas, is that what it is? Yeah. Gas cap. Yeah, was open on 300 of your trucks for 3 weeks. So that was, finding that would be an incredible leap forward for business to be able to say, wow, this one little thing could save us, X performance, X money. I mean, how simple it changed. But we can't find that yet. And that's part of the movement here of, we have all this data, let's do analytics, let's bring in machine learning. We finally reached the point where math is cool and it can do all sorts of things for us that will help business and help operations really resolve some of these problems that we've always known existed but couldn't find the root of.
Right. Yeah, totally agree. Well, Lori, this has been amazing, and just as I assumed, thank you very much for entertaining my questions and being such a good sport for answering the dumb ones even. And you're a prolific writer. You're regularly quoted, etc. Where can people find more of what Lori does, and follow you, etc., etc.?
Wow. Well, that would be Twitter, at L MacVittie, which seems pretty straightforward.
Yep.
Same on LinkedIn. So I try to share both places. And then f5.com, I usually post on our Office of the CTO, our Octo blog that just kind of compiles our content. So I try to keep it there. I also write for NWC for network computing. Yet my old testing days that I still miss them sometimes. There's nothing better than, right, just, I don't know.
Yep.
Lots of network traffic.
Yep.
So right there. So, it's
Awesome.
usually floating around.
Well, I highly recommend for anybody out there to pay attention. Lori is one of the brightest minds in this space, and always enjoy her content. So thank you again, Lori. Appreciate you being on the show, and look forward to catching up sometime soon.
Well, thank you for inviting me as always. I love talking to you. This is always good, and I get all sorts of new ideas from you. So really enjoyed it, and thanks for having me.
Awesome. Thank you.
Thank you for listening to the Edgevana Podcast. Be sure to subscribe to the show on your favorite podcast listening app or on YouTube. To learn more, visit www.edgevana.com. Thanks for listening, and be sure to join us on our next episode.